you'll have this to come back to, all right? And then we will, so let's discuss functions, and then afterwards we're going to take a look at like a little example of utilizing some functions, etc. Okay? Right. So, right, I'm going to start with it. All right, so what is a function? Basically, a function is a feature of the C programming language, and like all other programming languages, other programming languages that you all may have met so far, you might have done some functions. I don't know if you all did any kind of functions in Pascal or not. Did you?
Can't remember, sir.
I don't think so, sir.
All right. They might have called it by something else like methods or modules or something so. But in C, it's called functions. And you could divide your program into different blocks and call those blocks as necessary in order to prevent yourself from having to rewrite the same code over and over. Okay, so what a function is that a function is essentially a very specific block of code that you write to do a task. And the purpose of a function is to be able to write it in such a way that you are that it takes specific input and it gives, it may or may not give an output depending on its purpose. And really and truly, we've been using functions so far in C, right? So we've been using functions so far in C. And in terms of functions, as we want to talk about it today, we are looking at user-defined functions. Right? You all might have heard me talk about this before when I was talking about the built-in functions in C. Okay, and the built-in functions in C, for example, are things like printf, okay, scanf, getchar, right, rand, all of these different functions. And we know that some functions built in, we've been using them in such a way that our functions can accept a parameter or some sort of value. Like whenever we use printf, okay, whenever we use printf, we have to put at the very least, right, some string inside of here to print out. So a printf function needs to have some value passed into it, but it does not get any value from it. Okay, we don't return anything to printf, so printf doesn't return any values. Whereas the random function, when we call rand, let's say we want a random number between 1 and 20, we would say x is equal to rand mod 20 plus 1. And what this will do is this will return a value and store that value into the variable x. But we don't pass anything to rand. Okay, so that this function doesn't take any value. I mean, we've all been utilizing this stuff before. So I don't think that this is strange to anybody, right? Everybody know at least these built-in functions that I've called here, yes?
Yes,
Yeah?
sir.
Yes, sir.
All right, good. So what we want to get into is we want to get into understanding how we could write our own functions. We could write our own pieces of code that would allow for our that would allow for our programs to do specific things that we wanted to do. And we could write functions in such a way that it could be called from multiple different parts of our program. And this is kind of like the beginning of being able to have enough understanding to develop the solution that we would have to develop for our IA's problem, right? Because our IA requires us to have at least 5 functions inside of the solution provided. So let's just take a look at some notes about functions and what's the purpose of functions. Okay, so in C, we could divide a large program into the basic building blocks known as a function. And the function contains the set of the programming statements. We said that. So we put in that specific set of code that would allow us to do something special. A function could be called multiple times to provide reusability. So you could use a function over and over. And it modularity, which means that we can build a program step by step without having to actually build a program and see it existing with all functionality. You could now start to build step by step because your program allows for you to just simply call the functions that work. And I will show us how to do that too, right? And we have some advantages of using functions. If we use functions, we avoid repeating code. If you realize that you have a program to write and, within your program, you have to do the same thing over and over. If everything is inside a main, then you just, you would have to repeat that same block of code maybe once or twice in different sections of main to do the same thing. If you're repeating that code, you could just simply put that code inside of a function and call the function to be able to do it. Okay, you could call a C function a number of times from any place. You could track a large program easily when it's divided into multiple functions because now you start to think modularly. Functions allows you to reuse code, right? And of course, it's something to know that function calling is an overhead. It means that there is a resource penalty for calling a function because calling a function is like now calling a mini program within your program. And of course, if it is that you are operating under confines where you're limited in terms of how much memory you're supposed to use, etc., that could be a bit of a challenge there. We're learning right now, and I trust that all of our computers have enough memory. We're not programming under any set of constraints. We programming to be able to understand programming for now. So that last part we're not worried too much about it. So what do we know about functions? Right? We have 3 parts to a function. 3 parts to a function. And I'm just going with these notes that are on this website here. So, but this is important. And we need to know the different parts of a function. You have to declare your function. Just like you would declare a variable. Just like you would declare a variable in C when you would use a variable, you have to declare your function. You have to let the program know, hey, this program is going to contain a function. We have a function call. We have been using function calls all the time. Again, if you go back to this first slide, all of these printf, scanf, getchar, rand, those are function calls. Once you need to utilize the functionality of a specific function, then you utilize the function call. The function call is just where you call the name of the function and you pass information to the function. And then we have a function definition. And this is where our usage of this function call differs from the built-in functions that you would have used with the programming language. Because what you would get is that you will get well, whatever your code says to execute upon your function call, as opposed to the built-in, which is now standardized for everybody. If Ryan call a printf statement, Ryan shouldn't find a different printf statement in his version of C than Varun, right? Or Clay shouldn't call getchar, and you know it differs from Hannah's call to getchar. What if it is that Elijah decides to write a function named, do something, and David writes a function called do something? Because those are defined by Elijah and David respectively, then those two functions could be different in terms of their execution. You all follow me?
Yes, sir.
Yes, sir.
Yes, sir.
All right, cool. So, right, we have, say for instance, when we have a function, and we want to declare a function in C, right? Let's say we just want to write a function. So we write a function to accept two values and return their sum. Okay? If I want to write a program that uses a function that does this, the first thing I'd have to do when I'm declaring my program is to declare my function. And my function, when I'm declaring my function, I have to say, well, what's the return type of my function? So my function, to declare the function, I have to specify the return type. What value or what data type is my function returning? My function will return an integer. And then I specify the name of the function. And my name of my function could be add2. And then I could specify what data types my function must accept, right? So parameter types, right? Or type inside of here. And so inside of here, my function accepts two values, so it must accept an integer and an integer. So this is my function declaration here, right? So this is my function declaration here. And let's say, for instance, I go into main, int main, and I say int y is equal to add 2 for 5 and 20. I'm putting actual values inside of there. Then if I'm adding these two values, right, 5 and 20, and I'm storing it in y, it says that my return type needed to be an integer. I satisfy that criteria there. If I go printf $d y, right, this here is my function call. And when I call my function, I could pass values to my function. So these here are values passed to my function. And so I have to define this function somewhere for it to be able to work, because add2 is not a built-in function of add2 is not a built-in function of what you call this thing. Add2 is not a built-in function of C. Right? So I have to now down here say, okay, I'm defining this function that I declared. This int here is its return type. So it tells me that this function needs to return a value. Remember that return statement that I always seem to forget? Yeah? Right? Like where I actually should put at the end of my programs, and I sometimes forget to return 0, right? This return statement here actually is linked to this int statement here, because this int here where I type up my main code is a function. But the thing is, once I run main, I'm not really returning that value to anything. A program could choose to return a value to another program if it's called from another program, but we are not programming at that level. So int here, however, is a function within this program that was called by main. So I say int, and I have to put the same name, int, add2, and of course I need to have some variables to store the data that's going to be passed to my function. So I can name these variables anything. Int A and int B. And notice that I have, for each one of these, I have set over int and int. I didn't go int AB. I said int A, and the value that's coming from here is going to store itself in A. The value that's coming from here will store itself in B. Now remember, my function could have taken in 2 different data types, yeah? Right? My function could have taken in 2 different data types. So it's important to know that that's why we have to declare each one of these parameters which are accepting a value individually. We declare them individually. All right? So that's why I have int A and int B. And so when this function is called, the values, whatever values we in add2 is going to be passed to A and B. And then what do I want to do with A and B? I could say inside of my function, I could say int x, and I could say x is equal to A plus B. Return x. So what does this return x mean? This return x means whatever value is inside of x, where this function was called from, take the value of x and send it back to where it was returned. And we have y ready to take this value of x. So where I passed 5 and 20 in to A and B, and I said x is equal to A plus B, x of course now would be equal to 5 plus 20, which is 25. So when I say return x, the value of 25 is passed into y, so y is going to be 25. So 25 will print down here. You all got me?
Yes, sir.
Right,
Yes,
we
sir.
see it? Great. Yes, Joshua.
So the actual like math and calculations just go beneath here on an AD main.
Yeah, we do that inside of the function.
So this is the function here, the int
This-
R2.
This here is the function, yes.
Okay.
Right, and this is the declaration of function. So this is the not declaration, sorry, definition. And by that we mean that this is the piece of the program where we define what add2 actually does. Printf is defined somewhere in a C library. Scanf is defined somewhere in a C library. Getchar is defined somewhere. Rand is defined somewhere. srand is defined somewhere. String token, string len are defined somewhere. That's why in the beginning we say include stdio.h or include mat.h or include string.h, because that is where those functions are defined. But if we want to make our code modular, we can create our own functions. Yes, Hazard.
So int itself, when you're saying int, like mean is a function, that int itself is the function.
No, the function is add2. Int is the data type that this function is going to return.
Oh no, I'm talking about the main function, so the main function, int main. That itself is an entire function separately from.
Main is a function.
Okay, name of this main, okay.
Mm-hmm.
And it
Main,
does accept.
So every program must have at least one function, right? And that is the main function. That is the function that is defined from where all the program, where all of the program's activity has to start. So if a function does not have main in it, then it's not a runnable program. Sorry, if a program doesn't have main in it, then it's not a runnable program, right? That's something that you will see, especially when you go to university and you bounce up Java. You will have multiple programs. I'm using the term loosely by way of classes. And what will happen is that only the main class will be able to run something, but every other class, you could define functions there, but it wouldn't be able to run from there. So this main here it tells us that this is the main function that allows us to start our programming. Okay, so some things to note about functions, right? We identify that a function as a declaration. A function declaration, let's talk about function declarations here. If it is that I have int function 1 int char, what this means is that this function accepts an integer and a character and returns an integer. Let's say, for instance, we have char function 2 char array int. This function accepts a string, which is a character array, and an integer, and it returns a single character. If it is that I have something that says void function 3 int, this function accepts an integer and returns nothing. So when we have a function that returns nothing, we say that this function is void, right? The data type for its return type is void. And of course, if we have, let's say, for instance, a character, and we have function 4, right? Function 4, and let's say we take in an integer and a string. Sorry, no. I wanted to take in nothing, right? This character accepts nothing and returns a single character. So this function accepts nothing and returns a single character. You all follow me here? In terms of function declarations, So from the declaration alone, I'm able to know what my function is going to take, what values I could pass to my function, and what values I expect from my function. Somebody had a question? No questions so far? Everybody's fine?
No, sir.
All right, good.
So when you say
Yeah.
return, what do you mean? Like
When
when
I say
something like you return.
return means that where my function is called is a value expected or is a value not expected. So like with printf, there is nothing to return. We don't expect a value from a printf function, but we expect it to do something. Do not confuse the two. Doing something doesn't mean that something has to be returned. A printf function shows what you pass to it on the screen of the computer, but it doesn't return anything, right? So in this same case, add2 is expected to return a value, and that value is supposed to be a sum of the two values that were passed to it. So that's what I meant. That's what I mean by return. And so your return type, right? Your return type is either a data type or void. And if you expect something returned, you put a data type. If you don't expect something returned, you put void, right? So something to note about functions, right? A function can accept 0 or more values, right? But can only return 0 or 1 value. This is important to remember because your data type is limited to either the data type itself or void, meaning that it doesn't have anything. So you could accept as many things as you could list out in your function declaration. But then you could only get one thing back from a function. And it's kind of like maths, right? When you have a function in maths, how many values get returned to you? Just one value, right? One thing gets returned. But in maths, how many things could you put into the function? You put into the function as many things as you need to get your one value, that one answer that you have there. You all with me on this, right? You all with me so far?
Yes, sir.
Yes, sir.
Okay. So we're going to jump to our code and see our functions in action. Right? Any of you all took a look at the video that we did yesterday for the Canadian Computing Competition? Okay, we actually had a bit of a function inside of there, right? But we'll do it here. So func_eg1.c, and we're going to do a little bit of a function example. So we're going to start off simple, right? So we're going to write a C program that allows a user to enter two values, right? That allows a user to enter two values and passes those two values to a function. This program should return the power of the first number passed to the second number passed. So what we have is essentially if we pass in 2 and 3, right? We're looking for 2 to the power of 3. Everybody's fine with that? Everybody understand what we're asking, right? The program should return the power of the first number passed to the second number.
Yes, sir.
Yes,
But that's a math function already, though, sir.
It's a math function already, but we doing it for understanding's sake.
All right.
Because we can do things that's already done so that we can understand how they did it. Don't just take it for granted that it exists. All right. So we're not using math.h and the power function. Okay. So we go in. We naming it exponent or whatever, right? EXP or whatever. So if we're doing this, we're saying include, right? Include this. Include. And again, I'm still encouraging people, if I just say at this point, sir, I feel I want to try the programming contest. I'll squeeze your name in at this point, What are they for? Nobody? Oh, good boy. It's a tough crowd. Right? So let's think about the function, right? Let's think about the function. And I might include anyway, let's think about the function in general. And the function in general, we know that it has to return an integer. Yeah? We could give the function a name. All right, we could give the function a name. All right, let's name it to the power of. Why? Because we can name our functions whatever we want. And what we need, we want this first value to the power of the second value. So this is my declaration of to the power of, which should return the value of the first number to the power of the second. Okay, so this is our declaration to the power of, which should return the value of the first number to the second. The program asks us to enter two values, right? To enter two values. So we have to declare int A and B. And these are the two values that that the user will enter. These are the two values that the user will enter. And what's the next thing that we should do? We should printf and ask the user, of course, to enter the two values. So enter two integers separated by a comma. And we scan this, scanf, into %d, comma, %d, and store it in &a, comma, &b. Yeah? Everybody with me so far? Right? Elementary stuff. And then we put a getcha underneath here. That's for the purpose of putting a, cleaning up the input. And now we should be able to say, we should be able to get the results. I'm just going to jump and show you all a piece of magic too. Regardless of if you call this and store it in a variable that you define, or if you call it from inside of another inside of the printf statement, which is another function, it will return the value. So I could just simply say printf, right, %d to the power of %d is %d. And what do I put inside here? I put a, comma, b, comma, and I could put my function call inside of here to the power of a, comma, b. Right? %d to the power of %d is a, comma, b to the power of ab. This here is the same as doing this. If I had int z, and I said z is equal to power of ab up here, and then I put z down here, it is the same thing. Understood? It's just a matter of where you return the value to and which container you use. You all understand the difference between what I did there just now?
So go over, Daddy.
Right? No problem. We have, and I'll just undo, right? If I put the function here, the call to the function here, when this function gets executed, the value that is returned to where this function call is will be used because it is expected to be an integer. So I can put just a placeholder for my integer here and put this function call in place of a variable. So it comes like if I do this, which is say z is equal to the power of ab, and then I put z down here, because it's going to be the same thing. What is passed into z? This variable here is the same as whatever is passed from here. So when I have a, b, and z here,
They are all the
right,
same number. So
it's the same number as what would have been passed here. So you might see in some places that people don't really use these kind of little placeholder variables because it's not like using the contents of Z later on. Right? I just placing it inside here, right? I could put my return 0 here. And now I go down to declare my function. So this here is my function call, right? I called the function to the power of inside of the printf statement. And remember I said before, wherever your value is called, is where is where your value wherever your function is called is where the value that is associated with that function, if there is a value to be returned, will be returned. Okay?
Oh, so you can say it again. I get a real kind of break up. I didn't really hear anything.
All right. I said when my function is called, wherever my function is called is where its value is going to be returned. So if it is that I called to the power of inside of this printf statement, and I make provisions to capture the integer value which will be returned from this function, then it's just as good as putting an integer variable inside of there. We'll see it in action in a little bit. Okay? We'll see it in action in a little bit. So, yeah, Joshua?
No, sir. All right.
Okay. Right? So now we want to do the function definition. And the function definition is where we say what to the power of does. So if I have int here being my return type, it means that this function is expected to return an integer. And this here, where my function is called, is expecting to pass an integer to here to print out. So we're using it correctly, right? We're using it correctly. We say int to the power of, and now of course we expected to have two variables to take the values that were passed into here. We could name these variables anything. I can name it int x and int y. Because what happens is that a copy of the values inside of A and B will be placed inside of X and Y. So if this is 3 and this is 2, if this is 3 and this is 2, right, then if this is 3 and this is 2, then X is going to get the value of 3 and Y is going to get the value of 2. So let me see that. This tells me that my function should return an integer to where it was called, and the values from where it was called will be stored, and the values passed from where it was called will be stored inside of X and Y. So that's what this line tells me. That one line tells me a whole story, right? So you see why, as a programmer, it might be good. You're telling a story. Yeah. Okay, it's a story of two beautiful integers who got passed a function, and one got raised to the power of the other and returned. So, you know, it came back changed, and we let the world know through a printf statement. Wasn't that poetic? Yeah? All right. So ComSci is no different from literature. All right. All right. I know you all are laughing with me wherever you sit. Right?
Yes, sir, yes.
Or wondering what you've gotten yourself into. Right? But either way, we in it right now, and we have to get out to the other side of the CAPE examination that's supposed to happen in June. So, let's get it done. All right? And let's not panic about it. No need to panic. We have plenty of time and we'll learn. Okay. So to the power of int x and y. And so what do I do now? Right? I can say int r is equal to 1. Okay, and we want to, of course, return x to the power of y. So we need to multiply r by x, y amount of times, right? So we can say 4, and then we also have c as a count. For c is equal to 0, semicolon, c is less than y, semicolon, c plus plus. What do I want to do? I want to say r is equal to r multiplied by x. And what I should come out of this with is the value of x to the power of y, right? If I'm thinking correctly, but we'll test it out and see. Okay, and of course we have to return the value of r, because r is this value that has been accumulating y amount of times multiplied by x each time, right? So let's see if this works. I have an error in main because I forgot a semicolon on this line. Otherwise, the program was good. So enter 2 integers separated by a comma, right? 3, 2. 3 to the power of 2 is 9. So that works well, right? Let's see if it works otherwise with, right, 10, 5. Right, 10 to the power of 5 is 100,000, I guess. Yeah. Okay, and 4 to the power of 0. 4 to the power of 0 is 1. I think that's correct mathematically. Anything to the power of 0 is 1, not so? One of those math students, you could confirm.
Yes, sir.
Right, so we've written this function that now does this task here. And what happens is that anytime we want, right? I know it doesn't seem like much because you're still thinking that, well, this only gets called once. But anytime we wanted to do this piece of code, if we had to do it from inside of another function, it's here and it has a name. So once you could give your code a specific chunk of code a name, you could access that chunk of code anytime without having to write out the lines associated with that code. You all understand where I'm coming from? Yeah, Hazard.
So you could explain what I did in the for loop, sir? Because, yeah.
Yes, I could. Right. So the for loop, right? We have let's do it in a little table. Okay. So we have r, which is 1. We have x, which let's say is 2, and we have y, which says 4, right? And we have c, which starts off at 0. So c is 0, and while c is less than y, is c less than y? Yes, it is. So we say r is equal to r multiplied by x. So r multiplied by x, 1 multiplied by 2 is now 2. right? And then what do? We carry C up by 1. So C now goes to 1. Is 1 less than Y? Yes, it is. So 2 by 2 is going to be 4, right? That's what we get from inside here. The value of C goes up by 1. So 2 and 2 is less than 4. So 4 by 2 is 8, right? C goes up to 3. C goes up to 3. 3 is less than 4. 3 is less than 4 according to this line here. So we have to go in, right? 8 by 2 is 16, right? C will go up to 4. 4 is not less than 4. So the final value inside of R is going to be 16, which is 2 to the power of 4. You all with me?
So, sir,
Mm-hmm.
so the purpose of creating your own functions, even though, like, because I thought, like, when you say creating your functions, like, you wouldn't have to do all these lines, but the basis of it is, like, if you need to use it again, you don't have to go through all of it. So that's why you'll create your own.
Yes, and we will see it. We will see it when we come to doing file reads and file writes. Now, imagine if we had to continue. If we had to continue in terms of writing everything inside of one big program. When you have to do over something, you'll have two options. You could either use something that is depreciated in terms of programming, which is called a go-to statement, and it would have said, okay, if I reach all the way down to line 200, but I need some code that operates on line 14, I will have to tell my program, go to line 14 and do that code, and then I'll have to write logic underneath that says, okay, did I do the rest of that other code before, or am I doing or do I want to go through that code again? That's sloppy programming, right? But what we could do is that we could break our program up into modules, and our program from main will go to a particular module and start to execute what's in that module. And when we're ready, we could jump to another module, and then we could go back to maybe this module here. And from this module, we could jump to another module and go back to that module here accordingly. So what happens is once a module isn't running, it doesn't exist in the memory of the computer. And it actually have less code in any one given module, rather than having to have like this whole one big module where you're jumping from one part and then doing another, and then you're going back to another part, etc. And that could get messy as programming, right? So the thing is, it works so well, functions work so well that we don't, unless the language didn't support it and you're learning that particular language, go-to programming is not really taught anymore, right? It's not really even taught anymore. So, this is how we this is how we achieve code that we're able to manage. And the thing is that programming like this also gives you the advantage of maintaining your code easier and identifying errors easier. Because if you break your code up into modules and a specific part of your code is generating an error, then you know exactly where to go in that code. Or if you have to update that code, you know exactly where you go to update that code, right? So it's a plus for maintenance and it's a plus for updating.
Okay, so makes sense.
All right then. All right, so I'm going to pause now. We're going to take a little break. 10 minutes, and then we'll come back and do another example, okay?